All right. So step number one, just like we've been doing before, we want to factor the top and bottom if possible. So for this one, if you were to factor this, you should get x minus 1 x minus 1, x plus 3 on top, and then you have an x plus 3 on the bottom. Okay, so if I factor the top and factor the bottom, that's what I'm looking at. And then we can see that these two cancel. And so my simplified version is x minus 1 only. Okay. All right, so let's look at a couple things. So because there's nothing that doesn't cancel, there are no vertical asymptotes. Because I do have something that cancels, I'm going to take the thing that canceled on the bottom, I'm going to set it equal to 0 to figure out where that is happening. So at x equals -3, if there's a -3 here, that's 0. And so I have a hole at 3 comma something, right? And the x coordinate of the hole is -3. To find the y value of the hole, we are going to take the simplified version and plug in for x. So -3 minus 1 is -4. So that is here. So here I'm going to make a note. Plug into simplified version. Plug it into the simplified version to get the y value. Okay, so now we know exactly where our hole occurs because it is a single point. You call it a hole, but its proper name is a removable discontinuity. So it's just like you just literally like took one little teeny speck out. All right, vertical asymptotes done, holes are done. Let's look at the y-intercept. And so remember to calculate the y-intercept, plug in all zeros for x's. So that'd be 0 squared plus 2 times 0 minus 3. And then you'll have 0 plus 3. All right, so for this one, you plug in original. Plug in 0 to original. So for the y-intercept, you use the original, not the simplified. For the whole, you plug it in the simplified version. So 0 plus 0 minus 3, that's minus 3. And then this is positive 3, and so that should give me what? -1. So my y-intercept is 0, -1. All right, so let me just box these off here so you can see them. Okay, these are the things that are important. All right, now let's talk about the domain. You can figure out the domain without looking at the graph. Like, let me write it up here and then I'll explain what I did. So this would be -infinity all the way to -3, and then it'll start back up at -3 and go to positive infinity. So I'm going to show you on the graph why that happens. Just get that written down so that you can reference it when I put Desmos back up on the screen. So the hole is at -3, -4. And if we will come back to it. So okay. All right, so let's talk about the domain. You recall the domain is the x values. All right, so we're just looking horizontally from left to right and writing what values this function in red takes on. And so we go all the way from -infinity. And then as we're moving across, there is a break right here. There is nothing. That's why if you look at what we wrote down, there is a break exactly at this x value, okay? So like, so there's a break and then it picks back up. So holes will do that and the asymptotes will do that as well. All right, so we're going. We take a break at -3, then we pick back up at -3 and keep on going forever. Okay? All right, so let's go look at another one. All right, so domain is very closely related to the VA in the holes, the vertical asymptotes. So you need to find those first. All right, so let me make this point. Okay, let's do another. So let's go ahead and factor g of x in number 2. So if we fully factor this thing, you're going to end up with 2 times x minus 2, x minus, what do I write down here? And here on the bottom, you're going to have x minus 2, x minus 7. Right? So let's go ahead and simplify anything that will simplify, and that'll be this x minus 2 right here. And let's rewrite it in its final form. So that's 2 times x minus 5 over x minus 7. And so this one's the simplified version, right? Okay, so now let's start picking apart all of our stuff. So the vertical asymptote occurs at this one that doesn't cross out. So we have a vertical asymptote at x equals positive 7. I just took this and figured out where it was going to be 0, and that's at 7. Yes, ma'am?
On the last one, when x minus 1 didn't cancel out, why did I forgot the vertical asymptote?
This is in the numerator.
Oh,
And so
okay.
undefined behavior only happens in the denominator. Yep. All right. So from there, let's go look for our holes. So the holes occur at the one that crosses out. So this will be a hole at positive 2 something, right? I don't know what it's going to be as far as the y value of that hole yet. But to find it, I'm going to go plug it into the simplified version, this. So that'll be 2 times 2 minus 5 over 2 minus 7. So that'll be 2 times negative 3 times, or negative 5. So that'll be 6 over 5, which is the y coordinate of the hole. We'll do y-intercept in blue. Y-intercept, we plug into the original, right? Plug into the original. So I'll have 2 times 0 squared minus 14 times 0 plus 20 divided by 0 squared minus 9 times 0 plus 14. Which if you go through all of that, you're going to see it's just 20 over 14, which simplifies to 10 over 7. So the y-intercept here would be 10 over 7. Always mix those up. 0, 10 over 7. And then I listed the domain first, but we're going to do it last because we need to know where these interruptions in the domain are occurring in order to write it, okay? So interruptions happen at holes and the asymptotes. And so we're going to have multiple intervals. Starting at negative infinity, we go until we hit the hole at 2. Then we pick back up at 2. And we go until we hit the asymptote at 7. And then we pick back up on the other side of 7, and then we continue on to positive infinity. So you can have, you can have multiple intervals, right? So let me go back and show you the graph. I'll let you get here first. That's a lot. But I'm going to show you what it looks like. So, and I encourage you today as you're working through to not do the work from the graph, but to use the graph to check your work, right? To see if you're on the right track and kind of notice what is happening. So let's go back over to Desmos and take a look. This one looks like this. My hole is at 2, 6 over 5. I'm going to put it on here for us. There we go. And let's go ahead and correct the asymptote. So my asymptote was at 7. All right, so let's look a little more closely at the graph to see if we can kind of hash out why that domain is doing what it is doing. So as we move this way, right, we're negative infinity, all the way up until this point where there's a hole. That's it. We pick up on the other side and we go until we hit this asymptote, which is way more dramatic than the hole, right? But it's still an interruption in the values. And then we pick back up on the other side of that and continue on forever. So there are only 2 breaks that are going to occur in your domain, and that's going to be where there are holes and where there are asymptotes. So remember, the holes occur when you're crossing out factors in the denominator, and asymptotes occur when those factors are not crossed out. Okay, I think I'm going to do 2 more with you. I'm going to do 2 more just to highlight some different things, because sometimes you'll have a hole and sometimes you won't, and sometimes you'll have a vertical asymptote and sometimes you won't. It all just depends on how it works out. Okay, so let's go ahead, y'all. Factor 3 on the top. See how far you can get in number 3 on your own. It works out pretty clean, but if you hit a snag, that's cool. I'm going to go over it with you. Just take notice and let's fix that problem before we proceed. Okay, so you're going to factor the top and the bottom and then simplify it. Then identify the asymptotes and holes, y-intercept, and then go back up and finish up with the demo. If you're not sure if you're on the right track, then put it in Desmos. I'm going to give you just a few minutes and then I'll go over it with you and you can see how on track you are. Okay, so looking at what we've got going on here, the first thing I did was I factored the top and I factored the bottom. That's this step. Then I canceled the x minus 2, and then I rewrote the simplified version here, okay? First thing I did is I noticed that there was a factor on the bottom that didn't cancel, so that is my vertical asymptote. So I just set x plus 3 equal to 0. So I determined that undefined happens at -3. Okay. That's how I found my vertical asymptote with this. Next thing I did was I wanted to find the hole, and there is one because there are factors canceling. Okay, so the hole will occur at +2, and then I have to find the other location, right? Because it's one single coordinate. And so in order to do that, I took this and I plugged it into the simplified version, this right here. So I said, okay, 2 plus 2 times 2 minus 3 divided by 2 plus 3, which gave me -4/5. So that's where the hole occurs. Then I went back and to find the y-intercept, I plug in a 0 for every x in the original function. And I ended up with 12/-6, which just gives me -2. So that's 0, -2 for the intercept. And then finally, I went back and I wrote my domain using these values that get interrupted, right? This interrupts the domain. And so we went all the way from -infinity to -3, where there is an asymptote. We picked up on the other side of that asymptote, continued to +2, where there is a hole. And we picked up on the other side of the hole and then continued on. The graph is continuous after that. So let me look at the graph with you. And let's see if all of that adds up, right? So coming from the left, -infinity, -infinity, and then we hit the asymptote first at -3. Then the graph skips over the line kind of and picks back up and continues again until we hit +2, which has a hole in it. And we pick up on the other side of that hole and continue on forever in the positive x direction. So again, it's just basically negative infinity to positive infinity. And we have these little cuts that are made by either a hole or an asymptote. And so we include those in that same notation that we used for the positive or the increasing and decreasing intervals in the last unit. All right, I'm going to do one more with you. Let me go back over and do all the algebra first. Okay, let's do number 4. Number 4, and then we'll cut you loose. You have 2 things to work on for me today. Let's do this one first. So let's factor top and bottom. Top ain't going to factor. That's a done deal, right? Bottom is a difference of squares, x plus 3, x minus 3. Does anything cancel or simplify here? No, so there are no holes. But there are 2 vertical asymptotes. One at x equals negative 3 and one at x equals positive 3 because of these 2 non-simplifying factors, right? Right? And so now let's do the intercept. Be very careful when you're doing the intercept because here you're going to have 0 over 0 squared minus 9. That ends up being 0 over negative 9, which is 0. So y-intercept is 0, 0 here. And then the domain, I just have 2 breaks in it, here and here. And so I'm going to write negative infinity. Then we'll hit negative 3 and have to take a break. Then we'll pick back up at negative 3 and go to 3. Take another break. Pick back up at 3, go on forever. So you'll notice the number of breaks in your domain is equal to the number of holes and holes and asymptotes that you have. Notice I've got 2 breaks and I've got 2 asymptotes. So if you're ever unsure if you've gotten them all, that's how many breaks you should have. So let's go back over. I'm going to look at one more graph with you just to kind of confirm visually what we just did. Because again, I want you to do your very best to do these without the graph. But then I want you to kind of use that if you need to. Did I graph this one in the last class? No, I guess I'm going to have to do it from scratch. I'll do it because I love you. There's no hole. There are 2 asymptotes. There's one there. And then there's one at positive 3. I've just got to get the function in there because I don't think I have it from last block. All right. Now let me punch it in. So that's x over, here's the difference of squares. So it's x squared minus 9. Okay. So there's my intercept, right? I'm correct about that. There's my intercept. Here are my 2 breaks with the asymptotes at 3 and negative 3. So we go all the way from negative infinity. Then we hit that first break at negative 3. Then we pick up again. Then go to the next break at 3. Then pick up again. And we go all the way to positive infinity. Okay. All right. So I'm going to let you finish. These problem set on worksheet number 1, okay? When you are done with that, you have a second exploration today. So you'll need to come pick that up for me, okay? Well, that's it. Let me help you. Let me answer your questions. Some of these problems are engineered to kind of not work like you expect them to. So if you have questions, let me know so I can help you kind of understand and get past that. Check your work in Desmos. If you're not sure what's going on with the graph, look at it. I do not need you to save these graphs today. Yeah, baby.
Are we turning this into you after we finish? Like the
Yes.
number 1? Okay.
Mm-hmm. Yeah, you're okay. Okay. Yeah, just grab your agenda and check. So, you are. Hold on, baby.
You doing more on the back team album?
Hi, baby.
Like we doing the more on the back.
All turn in exploration package from yesterday. And pick up the new exploration. Yeah, the exploration packet for yesterday, so that big, so most of it should already be done. The first several pages should already be done, and then you're just working out the rest of the problems on the one that's called worksheet 1, which I think is the last page. And you're gonna come grab a second one. You wanna come grab it, Seth? Okay. What is it?
Can I go after her?
Yes, ma'am.